Looking at a few more equations, at first glance this seems to be a multiple angle situation where we've got sine 2x. However, I've got a sine of one thing and sine of something different in the same equation, and that doesn't usually work out well for us. So we need to see if we can come up with a way to rewrite this sine 2x using well, just a sine of regular x. And we've got the half angle formula, but I think what I'd like to do is just use the fact that sine of 2x is equal to 2 sine x cosine x. And we can use that to make a substitution. That gives us 2 sine x cosine x. And again, that's what these formulas are good for, is for allowing us to take something that we're not quite sure what to do with and rethink it in a new direction. So I have 2 sine x cosine x equals sine x. Now, a strong temptation right now is to divide both sides by sine x. And that would give us one of our answers, but it would make one of our answers disappear. So we don't want to do that. What we want to do is use our zero factor property. And to do that, we set the equation equal to 0, giving us 2 sine x cosine x minus sine x equals 0. At this point, I can factor out my sine x's, giving me sine x times 2 cosine x minus 1 equals 0. We have two factors whose product equals 0, and the only way that can happen is if the first factor, sine x, is equal to 0, or if the second factor, 2 cosine, oops, I lost my x on there, 2 cosine x minus 1 equals 0. So either sine x equals 0 or 2 cosine x equals 1 or cosine x equals 1/2. So now we need to look for values between 0 and 2 pi for which sine x is equal to 0. Again, we'll go back to our unit circle that we've memorized. Sine is our y value, so that's going to be 0 at the angle 0 and pi. We know it's also 0 at 2 pi, but we set up our restrictions so that 2 pi is not included. Only the 0 is included. That way we don't duplicate any coterminal angles. Alright, so we end up with our sine x equals 0. That gives us two values, x equals 0 and pi. Now looking at cosine x equals 1/2, that means our x value is 1/2. That would be up here and down here. And that would be at pi over 3. And in terms of 0 to 2 pi, it would be at 5 pi over 3. So that gives us cosine x equals 1/2 means that x equals pi over 3 or 5 pi over 3. And since either of these cases being true would lead to a product of 0, all four of these are solutions to this equation. Let's look at another one. Cosine 2x plus cosine x plus 1 equals 0. Again, x is between 0 and 2 pi. Once again, we see we've got what looks like a double angle or a multiple angle formula or equation. However, since we have the cosine x also, we probably want to rewrite cosine 2x involving cosines or cosines of x. So cosine 2x was that complicated one. It was cosine squared x minus sine squared x. But that would introduce a sine squared. I don't really want to get into anything extra. But it could also be written as 2 cosine squared x minus 1, couldn't it? And this would get rid of the sine x, it would get rid of the cosine 2x, and everything would be in terms of cosine of x. So I'm going to replace this cosine 2x with 2 cosine squared x minus 1. That's a direct replacement. And then I'm just going to copy down what I have left. Cosine x plus 1 equals 0. And now if I combine my like terms, I get 2 cosine squared x plus cosine x. My negative 1 and positive 1 eliminate each other, so I end up with a binomial, 2 cosine squared x plus cosine x. Again, same thing we did before. We will factor out what we can, which in this case is cosine x. And what's left behind is a 2 cosine x plus 1. And the only way this can happen is if the first factor, cosine x, is equal to 0, or if the second factor, 2 cosine x plus 1, is equal to 0. Solving each of these, we get cosine x equals 0. And we get, if you'll allow me to go ahead and do the math in my head, cosine x equals negative 1/2. So looking at our unit circle, cosine is our x value on the unit circle. So 0 would happen at plus or minus pi over 2, or since we're between 0 and 2 pi, we'd say it's at pi over 2 and 3 pi over 2. So cosine x equals 0 at x equals pi over 2 or 3 pi over 2. And then where is cosine of x equal to negative 1/2? Let's see, negative 1/2 would be there and there for my x values, and that would be at pi over 3 and 2 pi over 3. So there are our 4 solutions again. X equals pi over 2, 3 pi over 2, pi over 3, and 2 pi over 3. One last exercise. And this one's a little weird too. It's got tangent negative 2 theta plus 34 equals cotangent negative 2 theta plus 100 degrees. Theta is between 0 and 180 degrees. Again, we want to get these in the same terms if we can. And one thing, might be tempted to try to look at this as a sum formula, tangent of the sum of two different things, but that just kind of made it ugly when I looked at it that way. So let's see if we can think of, let's see, tangent of something, let's call it alpha, is equal to cotangent of 90 degrees minus alpha. Or the other way around, cotangent of something is equal to tangent of 90 degrees minus that something. So looking at it this way, we can turn this cotangent into a tangent. So I'm just going to recopy the tangent on the left side, tangent negative 2 theta plus 34 degrees equals tangent of 90 degrees minus whatever this blob up here is, negative 2 theta plus 100 degrees. And so 90 minus a negative, if we distribute our negative, we get that that's equal to tangent of, double negative gives us 2 theta, positive, and 90 minus 100 is minus 10 degrees. Now, there are lots of angles for which tangent of an angle equals tangent of another one. I mean, for example, we know that tangent of 45 degrees is the same as tangent of 225 degrees. They're both equal to 1. So this next trick I'm going to use would not work if it weren't for the restriction that they gave us. They said everything has to be between 0 and 180. And if the angle is between 0 and 180, there's only one angle for which tangent is the same, or there's only one angle for each tangent value. Notice this tangent 225 is outside of this realm. So I can safely say that if tangent of one thing equals tangent of another, then these two inputs have to be the same. Negative 2 theta plus 34 degrees has to be the same as 2 theta minus 10 degrees. That's the only way they can be equal, especially given that we're looking at 0 to 180 degrees. So now I've just got a linear equation I can solve. Let's see, if I subtract 2 theta from both sides, I get negative 4 theta. And if I subtract 34 from both sides, I get negative 44 degrees. Dividing both sides by negative 4, I get theta equals 11. So theta is 11 degrees.